Chapter 1.2 Day 3 Viewing Transformations. Vertical translation up. So for vertical translation upward, you're going to add the number outside of the function. So if the function is x squared, then you're going to add plus 4 with the function and plus 4 on the other side. So x squared plus 4. And the new function is called gx, which is moved 4 units up from the original function fx. For vertical translation down, in this case you're going to subtract the number from the function. So it's going to be x squared minus 4. So new function is gx, which is translated down 4 units from the original function fx. So for horizontal translation, you're going to add or subtract the number inside of the function. So for this example, if it is translated 4 units right, then you're going to have a negative sign already. If there is a negative sign already, then you're going to add the number here, that is 4. So x minus 4. So for translation to the left side, then you're going to subtract here inside this function, then it's going to be positive 4 because the two negatives become positive 4. Or you can just simply remember that way. If it is right, then it should be negative 4. If it is left, then it should be positive 4. Vertical stretch for the function fx. So write a function gx whose graph is a vertical stretch of the graph of fx equals x squared plus 2 by a factor of 4. So if it is a vertical stretch, then you're going to multiply the 4 with the whole function. So this 4 times fx means that you're multiplying the 4 with the function x squared plus 2. Then you're going to distribute the 4 inside. Then you're going to get 4x squared plus 8. This is a new function gx, which is a vertical stretch of the old function fx by a factor of 4. Horizontal stretch. For the horizontal stretch, you're going to get the graph, the new graph that is going to be a wider graph. In this case, you're going to only multiply the number with the x value. You don't have to multiply the whole function by the factor. So if it is a horizontal stretch, then you're going to only multiply the opposite of 4, which is 1 over 4, only with the x. So attach it only with the x. Now let's look at the horizontal and vertical shrink and reflection. So for vertical shrink, you're going to multiply this n with the entire fx. So which means that if we have a vertical stretch or shrink of a graph fx absolute value x plus 2 by a factor of 1 over 4, which is shrink, then you're going to multiply this 1 over 4 with the entire fx value. So 1 over 4 times absolute value x plus 2. So you're going to distribute the 1 over 4 inside. The answer is 1 over 4 absolute value x plus 1 over 4 times 2. 1 over 4 times 2 means that you're going to divide the 2 by 4. You're going to get 1 over 2. So the new function gx is a vertical shrink by the factor of 1 over 4 of the old function fx. So for horizontal shrink, it is the opposite of vertical shrink. If it is horizontal shrink by a factor of 1 over 4, then you're going to use 4, which is a fraction of 1 over 4. So the reciprocal of the number. So f of 4x equals, you're going to only now multiply this number by x. So it's going to be 4x plus 2. So new function gx, which is horizontal shrink of the old function fx by the factor of 1 over 4. For reflection over the x-axis, you're going to multiply negative 1 to the entire fx value. So negative of fx means that negative you're going to multiply with x squared plus 2. When you distribute, you're going to get negative x squared minus 2. So the new function gx is a reflection over the x-axis of the old function fx. Reflection over y-axis. In this case, you're going to multiply -1 only to x value. So when you multiply the x value by negative, you're going to get negative x square plus 2. So this negative x square means x square, which means that you're going to multiply negative x 2 times. So negative x square means that you're multiplying the negative x times negative x, which is going to be x square. So that's why this negative x square means x square and this 2 as it is. Now gx is a new function which is reflected over the y-axis of the old function fx.